because evasive malware is all about malware that trying to be stealthy, doesn't want to be analyzed, doesn't want to be detected. And one of the quickest ways that malware can be detected is running in a virtual machine or sandbox environment where malware analysts are poking at its code. So the first thing it wants to do is basically terminate itself, or what we call kill itself in the malware analysis community. It wants to kill itself, its process, because it doesn't want to be analyzed by malware analysts. All right, so what we're going to do now is we're going to, so just as a recap, we kind of bypass the registry key check that the malware does. We bypass the file system check that the malware does. And let's see what happens next. It's going to execute until the return, which is returning to my malicious code. Now we're back into our malicious code, our malware code. And if you look here in the RAX register, we see a value 809.
It's absolutely brilliant when a company like Brilliant sponsors this video. In tech, there's a really important skill that you have to get, and that's problem solving. You need to know how to apply your knowledge to a problem and to solve that problem. And that's where Brilliant comes in. They are an incredible resource if you want to learn, for instance, maths and computer science skills. What's different about their approach is it's very hands-on, it's very visual. You are actually involved in your own learning, which is really important. So their way of teaching not only allows you to retain information better, but also helps develop your problem-solving skills. You're going to have to solve problems during your learning, and that helps you build up the skill. I always say this, and it's something I believe in. You've got to keep on learning. Try and do something every day to improve your knowledge, to improve your skills, and to improve your understanding. It's amazing in today's world how if you learn a new skill, you can change your life very, very quickly. Hot new topics such as AI are covered by Brilliant. So go through that learning path if you want to learn about AI. They have fantastic resources, not only for beginners, but also for advanced tracks. They cover a whole range of topics that help you improve your knowledge and understanding. Brilliant offers a 30-day trial with a 20% discount if you use my link below, brilliant.org/David Bombal. I highly recommend that you look at Brilliant if you want to improve your skills. Fantastic platform. Really want to thank them for their sponsorship and for sponsoring this video. Hey everyone, it's David Bombal back with a very special guest. Kyle, welcome.
Thanks, David. I'm very happy to be here.
Kyle is the author of this book, Evasive Malware. Fantastic book, but I'm going to let you be the judge of this because Kyle has prepared a whole demonstration that covers 2 of the chapters in this book. Kyle, I really enjoyed reading your book. For everyone who's watching, I highly recommend that you go and buy this book. But, don't take my word for it. Let's have a look at the demo that Kyle has prepared, and then you can see for yourself if you enjoy the demo, which covers a lot of the content in the book. Just for everyone who's watching, for transparency reasons, I need to make you aware that No Starch did send me this book for review in preparation for this interview, but I'm not being paid for this. They have no input to what I'm saying here. So they're not seeing the content, they're not reviewing it or anything. But just for transparency reasons and because of YouTube rules, I need to make you aware that I was sent this book for free to prepare for this interview.
I have something prepared here, and it's a sample that it's actually doing quite a few really, really cool evasion techniques that will kind of highlight some of the stuff that I talk about in my book, but also it's using techniques that are very, very common in a lot of malware families. So this is just an incredibly practical demonstration for malware analysts, for security incident responders, or really anyone trying to learn more about malware, but more specifically how malware evades endpoint defenses. And this malware in particular is using some interesting techniques for sandbox evasion and virtual machine evasion. And these are 2 techniques that malware uses to prevent being analyzed in a sandbox environment or virtual machine environment.
Just wanted to say this is real malware that you've got, right?
This is actually a sample that, it's a great question. My original plan was to include real malware, but I don't want to say it's not because it's using the same techniques as malware uses. Basically, the evasion code is copied from real malware, but the payload or the actual malicious behaviors at the end are not real malware because I don't want to, infect my system or any people that may be analyzing this malware. Maybe some of your viewers who are interested, I can happily share the malware with them.
Yeah, that'd be great. I mean, if you can share it, is it used in your book or is this something just specific for this video?
This is just specific for the video.
That's great. I don't want to interrupt you, Kyle. People often complain if I interrupt guests. So I'm going to keep quiet now. You take the demo away and then I'll throw a bunch of questions at you.
Perfect. Yeah, sounds good. So today we'll be using several different tools that are actually free and well, I don't want to say open source because they're not all open source, but they're all free, which is the kind of the beauty of learning malware analysis, because most of the tools we use are just free of charge. A lot of them are open source, and you don't need some kind of enterprise expensive tooling or licenses to do a lot of this stuff.
Groovy, baby.
So we'll be using one of my favorite tools called Procmon, and I'll just give a quick overview of Procmon right now. And David, feel free to, I know you mentioned you don't want to interrupt me, but please do so if you have any questions, and I'm happy to answer.
This is from sysinternals, right?
Exactly. Yes, this is from sysinternals. Good point. Sysinternals is free on the Microsoft website. There's like 50 tools or something built into sysinternals, and this is just one of them. But it's really, really important part to malware analysis, at least for the behavioral malware analysis, which is what we're doing now. It's a very, very famous tool in the malware analysis community. And I should say that the tool is not just for malware analysis. I think its primary purpose was for debugging and monitoring, general system monitoring. But the malware analysis community got a hold of it and realized the value in it. And so this is a process monitor. And what we're looking at here, actually, I'm going to stop it, because what happens when you open process monitor, it immediately starts tracing the system behaviors. So it captures everything that's happening on the system, from processes being started or stopped to files being created or read or opened, internet communication, a lot of different things here. You can see registry keys being opened, queried, and it's doing it for all the processes on the system. And I mean, I've only been running this now for I think I ran it for 10 seconds, and it caught already 200,000 events. So there's tons of stuff to go through. And I'm running this now in a clean virtual machine, so there's none of this is malware. This is all just general Windows stuff happening. So you can imagine when you're analyzing malware, sometimes it's hard to filter through the crud. And so what we're going to do is actually let's go a little bit deeper here into Procmon, just so everyone kind of has a general awareness of the capabilities. So here we have, I will zoom in a little bit on this. We have our process names here. These are all the processes that are running on the endpoint. We have our operations, which is the most important part of Procmon, and this is the operation types that are occurring. So, for example, here's a registry key being queried. We have a file being read, a file being created. When you see create file, it doesn't necessarily mean that the file is actually being created as in from scratch. It could mean that the file is being opened. So this is what we call opening a handle to a file in Windows speak. But basically, create file could be opening a file for reading. And then we have, let's see what else we have here. A lot of junk that we don't care about. So what we're going to do for fun, we are going to just run our malware and see what happens and trace it in Procmon. So I'm just going to clear the filter here, which will basically reset our Procmon interface, or our filters. And I'm going to also reset the whole capturing and then recapture when we run our malware. So I'm going to press the capture button here. I'm going to run our malware. It's called updater.exe. And you can see a little box popped up on the screen. It didn't do really much else. And we're going to try to figure out what's going on here. So just in the, 2.5 seconds I had Procmon open, we've got 65,000 events. That's a crazy number. So what we can do to filter this out is we can just go to Tools, Process Tree, and we can see basically a timeline of all the system events or processes that were running on the endpoint. And this is really valuable because you can see here, if it's a full solid green, it means it was basically running for the entire time that I was capturing. And here you can see an anomaly. This was only running for a fraction of the time. So that's probably our malicious process. I mean, we already know it is because you know the name of the executable. But if you didn't know what was running and if it was malicious or not, this is a good way to find out. And then you can just right click on that and go to Add Process to Include Filter. Any questions so far, David?
That's just great.
So we have our process name here, which is updater.exe, and we have our operations. And we only have 239 events, which is very, very manageable. Let's see what's going on here. A lot of this is Windows stuff, basically Windows being Windows. We have here process start. We have a thread create, which is the code being executed. It's the code of the process. We have a lot of registry keys being opened. This is typical Windows stuff. Load images is libraries being loaded, kernel32.dll, kernelbase.dll. These are normal Windows libraries being loaded. Nothing here is really malicious. Let's go to the end though and see if we see anything interesting. Here we have a process exit, and this is where our process stopped. And if we look at a couple functions or a couple operations above this process exit, we start to see some registry keys being opened. And some of these keys are, for example, VmWare and Virtualbox guest editions. VmWare and Virtualbox, probably a lot of your audience knows, but maybe some don't. VmWare and Virtualbox are very common hypervisors, very common, they run virtual machines, very common in a malware lab environment, because most malware analysts are probably going to be using VmWare or Virtualbox as their hypervisor of choice. Maybe not, but that's the most common, I would say. And I happen to be using Virtualbox. And here you can see a reg key was opened, VmWare Inc., and you see here a result, name not found. That means that it didn't find this file. It's because I don't have it on my system. So we can ignore that. But here we see Oracle Virtualbox guest editions, and we see a success. And shortly after that, the process crashes. So that's kind of worth investigating. So let's click on this.
Is that why it just flashed on screen so quickly?
Exactly. Right. Exactly. So it shows the malware sample shows a console window because it writes some things to the console, which we'll see later. But it just flashed so quickly, and then it terminates. So that's why nothing happened.
Yeah, because I was wondering if it was actually running in the background, but it basically died, right? It terminated the process.
Exactly. Completely died. Yep. Completely died. And we can see that when we go to our process tree, we can see if it was running in the background, it would actually be, the lifetime would be extended. But here, it just, here's our termination basically at the end of that timeline. So that's kind of how we know. All right. And the really nice thing about Procmon is it's very interactive, and you can just right click on a lot of these values and just investigate. So let's right click on here and go to jump to, which will take us right to that reg key in our Registry Editor, which is another tool that you can be familiar. You should be familiar if you're analyzing malware. But here we can see our reg key, Oracle, and Virtualbox guest editions. So here is where it probably is detecting our virtual machine environment. But one fun fact about Virtualbox that maybe not a lot of people know is that it loads everything into memory when the VM is running. So all of these registry keys, you possibly could affect the performance by registering these keys, by changing these keys, but you're not going to totally kill your malware analysis environment. Like, for example, if you modify this, it will be perfectly fine for basic malware analysis tasks. So let's rename this to just really whatever. And we're going to do a test this theory here. Let's shut down. Actually, let's reset our filter, clear our trace, and then we're going to capture a new capture here, and then run our malware again, and then we'll stop our capture, doing this, going to the process tree again here. And here we have our updater. I'm going to once again add this process to the include filter. All the way at the bottom, we see our process exit again, but we see a little bit more this time. This was where our registry key was open last time, and remember, it crapped out about 4 operations after that. And now we have some more stuff going on. Oh, by the way, we have a name not found here, which means that this key was not found because we renamed it. And here we have the malware also looking at the BIOS vendor, which is another common technique. I will open this key. Actually in Virtualbox, it's not populated, so I won't. We're not going to talk about this one. This one was mainly a VmWare check, but if we were running VmWare, it would have also detected VmWare here. And then here we see a create file, which is actually opening the program files directory, and we see a query directory for Virtualbox guest editions. So if we jump to that, we can see that this folder does exist on my endpoint because I have Virtualbox installed. And for the same reasons as I mentioned with the registry key, you can just rename this whole directory without affecting your virtual machine. And we are going to go through this process one more time. And you might be able to see that malware analysis is a lot of trial and error. Trying things, the malware detects your VM or environment or whatever, try something else, detects it again, and eventually you get it. So that's kind of the joy of malware analysis, right? Actually figuring out what the malware is doing and how it's doing it.
So I'm a bit slow, right? So this is an example, like your book title is Evasive Malware. So this is an example of malware trying to be evasive, right? It's trying to check if it's running in a virtual machine. Did I understand that right? And then if it is, then it dies. Is that kind of what it's doing?
Exactly. And that's actually a really, really good point because evasive malware is all about malware that trying to be stealthy, doesn't want to be analyzed, doesn't want to be detected. And one of the quickest ways that malware can be detected is running in a virtual machine or sandbox environment where malware analysts are poking at its code. So the first thing it wants to do is basically terminate itself, or what we call kill itself in the malware analysis community. It wants to kill itself, its process, because it doesn't want to be analyzed by malware analysts.
So Carl, I'm slow once again. That malware is doing a check against the registry, and then it's doing a check against the file directory. So those are two kind of checks. Is that kind of right?
Exactly. They're two of the most common checks that malware makes: different registry keys and files on the file system.
So checks to see if it's running in Virtualbox or VmWare, because it doesn't want guys like you to basically analyze it. So it checks the registry, checks if it's running in Virtualbox or VmWare. If it is, it kills itself. If that is okay, as an example, it will check the file system for specific software that's installed in a virtual machine. If those software types are found, then it kills itself again, right?
Exactly. Well, it kills itself. It kills itself once, but we bypass that first check. So then it goes to the second check because that first check was basically bypassed. All right. So what we're going to do now is we're going to, so just as a recap, we kind of bypass the registry key check that the malware does. We bypass the file system check that the malware does. And let's see what happens next. So we are going to capture again. We're going to run our malware again. We still get the pop-up with not much else. And then we're going to, once again, the audience is probably pros at this now. We're going to just set this to the include filter. And let's see what's happening here. So now there's a lot more stuff going on. We had our file system check here. Says no such file, so we bypass that successfully. Then we start to see some interesting keys, registry keys related to possible languages. So we see, for example, machine language configuration. We see the MUI, which could be the user interface settings. We see machine preferred UI languages, which is the preferred user interface languages. So the malware is probably, based on this, could be looking for some type of indicator that the victim system speaks a certain language, right? And this is also a common malware technique, and we're going to look into this now. But we're actually going to switch to a different tool to do this, and we're going to go to the tool called x64 debug. So this tool looks scary, but it's easy to get the hang of once you kind of start working with it. But I'm going to actually close that down. I'm going to open it up by just dragging the icon of the malware to the x64 debug application. All right, and here we are. So I think it probably would be helpful to give the audience or give everyone who's listening a really brief intro into x64 debugger. These are all the CPU instructions that this malware is going to execute. And they're listed as opcodes. And opcode is basically like an assembly instruction, or telling Windows what the malware should be doing, essentially, or basically instructing Windows or the CPU to execute those instructions. And so that's on the left here is all the opcodes, CPU instructions that are going to be executed. And on the right, we have the different CPU registers. So on every CPU, there are different types of registers, different number of registers, and these registers, the important thing to remember is they basically store information. They store memory addresses, they store values that need to be calculated, etc. So these are all the different registers that are on my system. And then we have here the stack window, and the stack window is basically a memory address range that the malware, or well, I shouldn't say malware, all Windows programs use stacks to store information. And then in the far left corner we have the memory dump window, which is it shows the raw memory of whatever I'm interested in seeing. So for example, if I want to see a certain memory address, I can right click on the address and then go to follow and dump, and then it will show me what's in that memory. Like I said, this looks super scary. The important thing here is that we're going to be focusing mostly on the CPU, the CPU registers here, and the CPU instructions that are going to be executed. And there's a helpful icon here called Run to User Code. Like I said, here's the instructions that are about to be executed. Windows has to load this, it basically has to load the process into memory. It has to execute the first threads of instructions. And a lot of these we don't really care about. And that's why x64 debug has this option called Run to User Code, which if you click it, it goes to the user code, which is the code that we're actually interested in. This would be the likely the malicious code, or the code of the actual malware that's about to be executed. So these are the instructions that are about to be executed. And if we go back to our procmon here, we can see, as I mentioned, the language settings possibly being queried. And one way to do that in Windows is with a function called, it's called get user default UI language. And I'm going to set a breakpoint on that function. So if I type in BP, it's breakpoint, get user default UI language. That's going to set a breakpoint at that function. And a breakpoint is essentially a way to pause the debugger when that breakpoint is hit. Because in a debugger, you could step through the code by pressing F7. F7 will be step, 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 step. It's a very, very slow process, though, because there could be thousands, hundreds of thousands of lines of code, and you'll be here all night stepping through this. So if we go to if we just set a breakpoint, we can run to that function that we're interested in, and it will break there. So we're going to do exactly that. We're just going to press this run button, and we braked here, or we braked. Not sure what the proper English is in this term, but we have a get user default UI language, and that's where we are. So let's press F7 to step into this function, and this is we're actually in the function now of get user default UI language, meaning that we're actually in Windows code, and we don't care about Windows code. We want to look at our malware code. So this is the actual function that's going to be executed. And at the end of this function, we're going to have a value, and that value is going to be the language, the UI language of my system. So if I just press this button here, execute till return, it's going to execute until the return, which is returning to my malicious code. Now we're back into our malicious code, our malware code. And if you look here in the RAX register, we see a value 809. So 809 is actually the hex code of the British language, the British UI language. And if we go here to exactly, yeah, I thought you'd find that interesting being in the UK.
Of course, yeah.
And if you see here, my keyboard language is actually set to English United Kingdom for whatever reason with a German keyboard. So I have a very international system set up. And so 809 is basically the language code of my UI right now. The malware is probably checking for a specific language. And let's see what we can find here. As I mentioned, we already returned. Here's our call to our function get user default UI language, which we already returned from. So here we are now, and we can see a value 407 being moved into the ECX register. The important thing here is that 407 is actually the German language for the system.
Interesting.
So it's probably going to compare 407 to 809. So let's see what happens here. Yep, exactly. So we have a comparison operation comparing 407 to 809. And it doesn't take a mathematician to realize, that these values don't match. So it's probably what's going to happen is the malware is going to terminate if our system is not configured to be the German language. Let's just test that theory real quick. So we have our comparison here. This is the comparison to 809 to 407. It's comparing our keyboard, our system languages. And here we have a jump if equal. And if these are equal, it's going to take a jump. But because these values are equal, it doesn't jump, and it basically goes right into this function get current process, and right below that we have a terminate process.
Just to clarify, it's because they're not equal that it terminates, right? If it was equal, it would have processed. Is that correct?
Exactly. Yep. And we're actually going to see that right now. I'm going to let this malware terminate itself by running. It's just going to terminate itself. And we're going to play around a little bit with this malware and run to user code again, and we're going to jump again.
Carl, why would it check languages?
That's a great question, and it's for multiple reasons. Since my book is based on malware evasion techniques, I talk about malware that checks languages for evasion purposes. And this is it does this because if let's say if you have a sandbox, a malware sandbox or a virtual machine environment, and a lot of sandboxes are configured to be default, and a lot of Windows installations are default to whatever regions you're in. And a lot of the times that's in, for example, the US. So you might have a US version of Windows, even if you're living in India or wherever. So your default language in a sandbox possibly will be English. So a sandbox is or if malware is checking these language parameters to see, okay, what is the language? And first of all, could this be a sandbox environment based on the language? But more commonly, malware is using this to do what's called guardrail techniques. And a guardrail technique is are similar to sandbox evasion, but a guardrail is ensuring that the malware doesn't infect unintentional victims. And it might do this for many, many reasons. But this malware could be targeting German speakers or people in Germany and doesn't want to target other countries. for whatever reason. And this is a way for malware to kind of stay on target and on point.
You used a really good example in the book, Stuxnet, which is the famous one, right? And then you use SolarWinds and I think ASUS. And like right in the intro, you're talking about that. And I mean, I'm going to explain it really badly. But in those examples, is that kind of the same thing? It was checking, like in Stuxnet, that it was on a certain computer or a certain device with a certain language or something, and then it ran?
Exactly. These are all three of those different scenarios are types of guardrail techniques, but it could also be considered sandbox evasion techniques because a byproduct of guardrails is that a lot of times it won't run in a malware analysis or sandbox environment.
So Stuxnet, in that example, it would only run on, it was checking to see if for a certain condition, and it would only run if it was in a specific environment kind of thing, right?
Exactly. Yeah. If I recall, Stuxnet was looking specifically for a very specific version of Windows, and it was also looking to see if it was running on a controller, like a logic controller, a certain type of logic controller. And so these are very specific. This is a very specific environment. So anyone that was running Stuxnet on their malware analysis system or in a sandbox, it highly likely didn't execute correctly, and this prevented analysis for certain Stuxnet variants.
I love that you're doing this demo because, you know, it makes the book come alive. And I just want to reiterate, you cover this kind of stuff in the book, right? So you're giving us a really cool demo of what's in the book, but this kind of stuff is covered in the book and in a lot more detail, correct?
Yeah, it is. Yeah, exactly. This demo itself, the whole demo is actually, it's unique to your channel right now. But in the book, I do mention this function and all the techniques that we're learning here, but more piecemeal. I didn't have it in such a clear demo, if that makes sense.
Oh, that's great. Sorry to interrupt the flow, but I mean, just for everyone who's watching, Carl gave me a demo in preparation for this video. And I mean, what I told my team is, you know, when I went through the demo, you know, the penny dropped for me. So this is fantastic that you're doing this. I really appreciate it.
That's awesome. I'm so happy to hear that. I'm glad it's valuable. So now we are at our get user default UI language again, and we're going to kind of play with the malware a little bit to trick it into thinking that we're running on a system that that it's looking for, right? So basically via its target language. So once again, we're going to return here. I kind of already covered all this, so I won't cover that again. But here we see that 407 is being moved into the ECX register. We're just going to modify this by going to assemble, and we're just going to type in 809 and basically tell the malware that there's actually a couple ways we could do this. We could basically tell the malware that basically modify the return of that UI language check and just say that, you know, we are the German language, we are configured in German language, or we can actually modify the malware's code and tell the malware, no, just look for the UK British language. English, not German. And that's what we're doing here. We're just going to say, okay, we're going to look for instead this language and not the German language. And something really cool here is we can go to File and Patch File. And this will allow us to directly modify the malware's code. So this won't just be in this debugger session. This will be completely, every time we run the malware now, it's going to be completely, the code is going to be changed to look now for the language that we tell it to look for. So we're going to do that, and we're going to call this updater 2. Actually, let's call it updater patched, and save that. All right, so we saved our patch file. I'm not going to close down this debugger session since we're still running. If I need to rerun the malware again, I will run my patched version of the file so that it completely bypasses this check. So now we're moving on. And we're going to do our comparison operation. It's comparing 809 to 809. It's going to take this jump here. And now we're firing on all cylinders here. And we completely bypass that. And now let's see what happens here. I'm just going to, let's do this. Let's open up 2 windows here. Hopefully this is not too many windows. I've got the console window that the malware is, if you recall, when we initially ran the malware, it spawned this window and stopped. But since we're running this in a debugger and the malware's paused, this is paused as well. So we're just going to run this malware and see what happens. So here we are now. We are at the breakpoint for get user default UI language again. I basically restarted the malware sample because I want to show the next technique and also show how we're bypassing the language check that we already patched the malware for. So we're going to return again. And now you can see here that instead of moving that 407 value into EAX, it's moving, or ECX, it's moving 809 into ECX. So basically it took that, it accepted that patch. We modified the code, it accepted it, and now it's doing a comparison against 809. And so we're going to skip over all these terminate process checks. What I'm going to do here is kind of monitor the malware's output here at the same time. And we're just going to go run. And we see here a message saying that software is updating. And then you can see here in the debugger that the malware is running, right? But it's not really doing anything. And we can confirm that by actually looking, if we do another filter on Procmon and we clear our filter, capture our behaviors again for a little bit, and let's stop, and then we can look at our process tree and just see, here's our updater. Okay, now we're capturing the malware's behaviors, and it's not doing anything, it's just saying updating software. And we can stop capturing and go to the process. And you can see here, we have nothing here, even though the malware is still running. And in the debugger, we can see that the malware is running. It says running down here, but nothing's going on. This tells me that the malware is in some kind of a sleep routine, and we need to figure out why it's doing this. So we're going to kill this malware. And sleeping is a common form, another common form of evasion, and for a couple different reasons. One is Sandbox evasion. One malware detects that it's running in a sandbox, or even if it doesn't detect it's running in a sandbox, maybe it just executes a sleep routine for, basically it's trying to outlive the sandbox essentially. Because malware sandboxes, when they run malware, especially the automated sandboxes, they're going to run the malware maybe for 1 minute, 2 minutes, 3 minutes, and then they're going to terminate the malware sample and then move on to a new malware sample. Because you have to remember that a lot of malware sandboxes are analyzing malware at scale. And so 3 minutes is usually just enough time to analyze the malware. But if the malware outsleeps the sandbox, maybe it goes into a sleep routine for 5 minutes or 10 minutes, the sandbox won't properly detonate the malware, and then it can't understand what the malware's behaviors are. If a malware sleeps on an actual real victim system for 10 minutes, I mean, it doesn't really matter, right? Because usually the victim user is doing stuff in the background. They're doing a PowerPoint or watching YouTube videos or whatever, but all this is going on in the background and they don't care. So it's only malware analysts and sandboxes who are kind of upset about this. So we are going to restart the sample and jump again to, well, we can actually just jump again to our get user default language because we still have that breakpoint on that. And now I'm going to set a new breakpoint on something called delay execution, which is a function for exactly doing what it says, delaying execution. And it's essentially a way that malware can sleep. And I'm going to run to my breakpoint. And here we see something was printed to the screen, updating software, which you already saw. And we have the delay execution function is being called here. What we're going to do though is we're going to backtrack in the code a little bit to try to figure out where delay execution is actually being called, because right now we're actually at the breakpoint where Windows is about to invoke or run the actual code for delay execution, which we don't care about this code. We care about how the malware called it. So we can go to the call stack window, which will let us walk backwards to where the function was being called. So I'm just going to go here and go follow to, which will take us to here. Here is where we had the check for the language here, our check for 809. And then remember, the code was going to possibly terminate here, but we jumped over that instruction. And now we had several other instructions, and we have a call rex, which is actually the NT delay execution. You can see it right here. So this is where NT delay execution is being called.
Yeah, Carl, so just to reiterate, to make sure I understand, we stopped it from checking the language and then breaking out of it. We see that it now goes into the sleep mode, and that's what we're seeing now, right? Where it delays itself for a period of time.
Exactly. It's trying to outlive a sandbox, outlast the sandbox. It's also trying to annoy malware analysts who are debugging, because as you could see, when the delay execution was being executed, the malware was just hanging. And we kind of lose control of the malware because it's in a sleep routine, and we can't get control back until the sleep routine is completed. But instead of jumping into the sleep routine, what we're going to do now is just modify it so it doesn't sleep. So here's our call to NT delay execution. And instead of doing this call, we're going to just do something kind of cool here. Just fill with nops. And a nop is it's an assembly instruction, but it just means no operation, meaning that it's going to completely jump over that area of code. It's essentially no operation. And there's a lot of uses for NOPs. But one of the cool uses is patching out code that's problematic and just making it not do that thing. And so what we just did, we knopped it out. Basically, now it's not going to run that instruction. But the other problem, though, is after that NT delay execution was supposed to run here, it tests EAX against itself, meaning what it's doing is it's checking to see if that function call was successful. And because we knocked it out, it's not even going to run. It's not going to be successful. So what we need to do is modify this instruction as well to trick the malware into thinking that the instruction was successful. So what I'm going to do here is right-click on here and go to Assemble. And we're just going to simply change test to XOR. And test was the instruction to see if the it's basically testing to see if the function was successful. XOR is essentially setting the register to 0, because 0 in this case means that it was successful. So we're basically just saying, yes, your function call was successful. And we are also going to save the malware again. So I'm going to go here to patch file again and patch file. And we're going to call this updater patched, and we'll call it patch 2. And the reason I'm doing this now is because I don't want to keep on bypassing all these checks. I just want to save these checks or save these modifications. So that way, if the sample crashes or whatever, I want to take a break, I can just go right back into it again with my patched version. Okay, let's just kill this session here. And we're going to start a new one with our patched malware. Actually, you know what? Let's not even use the debugger. Let's just execute it and see what happens. So now we're executing it. We're getting updated software. And now we get something new. The updating software, that was supposed to be the sleep routine. But since we patched it out, it doesn't even exist in the malware anymore. Now we see downloading update. So it's something new. That's kind of interesting, leading me to believe that it's probably trying to maybe download something from the internet. But in a normal sandbox environment, or a lot of sandbox environments, there is no internet, right? Because a lot of times for safe malware analysis, you don't want to be connected to a network. And right now, I'll just double check. I basically am not connected to any network. So no internet access, just for safety reasons, because I don't know what malware is going to do. I don't want to be on the internet unless I know what it's going to do. So we're going to fake the internet by using Remnux here, which is another VM. Remnux is a really awesome malware analysis Linux VM with a ton of tools on it. But what we're going to be using it for is a gateway for our Windows system to basically tell any processes that try to communicate with the internet. It's basically going to say, yeah, we're the internet. So we're going to start up Remnux.
Carl, this is taking a while to boot up, so perhaps you can answer this question. Remnux, if I'm pronouncing that right, is this what you'd always use, or is there other like VMs or software that you'd use?
So Remnux is usually my go-to Linux environment for analyzing malware, because it has a lot of really good command line tools. It's got a lot of tools that you just can't get running in Windows correctly. It's usually my go-to even for internet simulation and gateway. But really, you can install these tools in any environment, even on Windows. So, for example, I'm using today a tool called INetSim and a tool called Fake DNS, and these fake different network services. So you could install these directly on Windows. You can install them in any Linux distribution you want, I would say within reason. I'm not sure what the limit of that is. But the nice thing about Remnux is they work out of the box. You download Remnux. It's a free VM. You could probably link it in your show notes, David. I'm not sure if you have those notes or not.
Yep.
But Remnux is just out of the box. Everything works. That's why I like it. So this is Remnux, and I'm simply going to configure Remnux to be our gateway for all of the network services or network requests coming from Windows. So to do that, I'm just going to type accept all IPs start, which is a great example of why Remnux is really awesome. This automatically configures IP tables, which is the local firewall, to accept all connections. This would be a real pain to set up on from scratch on your own distro. So this kind of stuff is really nice because Remnux is just ready to go for this kind of stuff. So then I'm going to type in INetSim, which is going to start up all of our network services. You can see here, we've got a fake SMTP running. We've got a fake, email POP3 stuff going on. We've got some HTTP and HTTPS, which is what we really care about. But it allows you to set up a ton of fake services, and you can set up custom services. And also, there's a lot more than just these 10 or so here. There's quite a few you can set up. But for our purposes, this is all we need. And then we're going to start up a new tab here and just type in fake DNS, fakes the DNS services, because iNetSim also can do that, but out of the box, I find that fake DNS is a little bit better for DNS interception. And here you can see Windows is already doing some Windows stuff here. We got Edge communicating outbound, because you know how Windows is. Everything's got to talk to everything else. So let's see if we're successfully connected here, though. We can just open up a browser. CyberChef is opening. I didn't want to do that, but that's okay. CyberChef is another great tool, but we're not going to cover that one today. I'm going to go to Google and see. You can see here that it says this is the default HTML page for iNetSim HTTP server fake mode. So that tells us that the iNetSim is working and we are getting our traffic intercepted. So what we're going to do now is run our malware sample again, our patched version. And here we have downloading update. We have an update successful, and we can verify that in Remnux. And we have a lot of network connection, but all these are just, Google being Google and Windows being Windows. And then we have here Blue Lake Resort.site. So that's kind of suspicious, right? Anything with a .site is suspicious, in my view, at least, coming from a malware background. So that's probably our either a download communication, like a download request, or possibly a command and control server. But the cool thing is, we got the malware to talk by bypassing 6 or 7 different techniques that the malware was using. I mentioned at the beginning that this was synthetic malware, maybe meaning that I made it, or I basically copied the code from a legitimate malware to kind of sanitize it. But this is all real malware stuff. I mean, malware is doing this all the time. Malware that I'm looking at on a daily basis usually has a lot of these checks in there. So what you learned today is very valid for the real world malware analysis.
That's fantastic. I mean, it's important to highlight, and I'll just highlight this again for YouTube. You have created this like fake malware, if you like, but it means that we can share it because there's nothing malicious in it. It's just showing the process that you've demonstrated.
Exactly. So you mentioned, David, what Windows version this is, or what environment this is. This is Flare. Yeah. Flare is also my go-to Windows malware analysis environment because it's basically all inclusive, kind of has tons of tools. We can kind of look in these tools right now and see what we've got in here. But basically everything you would want, and you can pick and choose which tools you want. They have a very nice kind of interface for installing and uninstalling tools. So you can install basically a very bare bones build, or you can just basically get everything that's out there for malware analysis already ready to go, set up. And the coolest thing about Flare is it's all maintained in packages. So you can just type in like a Flare update, and it will update the entire all packages for you. If you've ever tried to manage your own malware analysis environment without these type of package systems, it's very, very difficult because you have to manually update all your software, and there's tons of tools and everything. So this is very, very convenient. And there's tons of stuff here, a lot of different debuggers. You've got memory analysis tools, hex editors. I mean, even exploit and malware development tools. If you're into that kind of thing, they've got it on here. Just tons of stuff.
So, Carl, I got to ask the question. I mean, this is the end of this demo, right? But you've got many, many more tools and cool things that you can show us, right? Perhaps in another video. Exactly.
Yeah, and I'd be more than happy to. I love teaching, and I love showing new techniques. And well, actually, these techniques aren't exactly new, but I love showing how malware is evading and how malware techniques are being used in the real world. So I'm very happy to be on the show again.
So for everyone who's watching, please put your comments below, the kind of stuff that you'd like Carl to demonstrate. This was a fantastic demo. And we need to talk about your book, Carl, because this is the book that you've written. And I'm so glad that you've shown us like visually and practically the kind of stuff that you've written in your book, and sort of like give us the synopsis of what the book is about, or the summary of what the book is about. I'm assuming, like we've been discussing, I mean, you've shown a bunch of stuff here, but you're covering much, much more in the book, right?
Yeah, covering a lot of different things in the book to different levels of detail. The book is, well, maybe I'll start by telling you why I wrote it. And I was working in one of my previous employers probably about 7 years ago. I was looking at malware and noticed kind of a trend in how malware is using evasion techniques. I mean, it wasn't always like this, right? Malware didn't need to be so evasive because sandboxes just weren't that prevalent. EDR and anti-malware controls were not as great. And malware has had to kind of adapt to newer technologies, newer EDR technologies, newer anti-malware controls and things like this. So, and I noticed how malware is just trying to really hard to detect virtual machines in sandbox environments, and kind of noticed how this was becoming more of a problem and just more of a bigger thing. And that kind of got me really interested in researching that area. And then after researching it for about a year, I realized that there's no good book on this topic. I mean, there's a lot of good malware books, like Practical Malware Analysis, which is the first malware book I read, also from No Starch, which is really, really good. They're not paying me to say this. And that's kind of how I learned malware analysis, but it doesn't cover, it covers some evasion techniques, but that's not the whole core premise of the book, right? The book is basics of malware analysis. And then I realized, there's no real good book on this topic that kind of covers all these different techniques, kind of a one-stop shop for learning about these different things that malware is doing. So I was hoping that this book would address this need, and I really hope it fulfills that. Also, I love doing my own research and learning, so I have to say writing a book is the best way to learn about a subject because you're kind of forced to learn it.
I love what you've done in the book, right? Because right at the back of the book, I mean, what you've shown here is fantastic, but in the back of the book, you actually show us how to build our own environment, right? Exactly.
Actually, this environment that I have set up now, all this is discussed in the book, and a lot more, to a great level of detail. I discuss a lot of those registry checks that I ran, that the malware was running at the beginning, as well as the file system checks and the language checks and everything. In that chapter where I discuss how to build a lab, I talk about how to kind of sanitize your lab so malware will never even run into those artifacts in the beginning. So a lot of these techniques for bypassing this stuff you might not even have to do because your environment will be a little more sanitized.
In the book, and I'm assuming here you use Virtualbox, right? Is there any reason why you prefer Virtualbox, say, to VmWare or other hypervisors, or is it just personal preference?
It's personal preference. For work, but actually on all my previous employers, we were using VmWare. Because of course it's a paid for license, right? But for private use, I use Virtualbox because it's free, but I would say 95% of the features are available in Virtualbox, just like they are in VmWare. So the comparison really is really equivalent, I would say. So it's really personal preference and what you have the budget for.
I mean, one of the questions I think a lot of people have, Carl, is who's the book for? Do I need to be an expert, or if I'm just starting in this stuff, is it also for me?
Definitely. I would say some malware analysis background helps, especially understanding the later chapters where I get into EDR evasion and things like this. But I also include 3 chapters at the beginning of the book where you can learn about different types of malware analysis, dynamic malware analysis with Procmon, for example, like we just did in this demo. You can learn about even the basics of assembly and disassembly. Even if you're starting from square one, it's a great book to kind of dig in. And it's a book I wrote it initially for malware analysts because I'm a malware analyst. So, that's kind of what the language I speak. But then I realized as I was writing that it's also would be very valuable for security operations center analysts, SOC analysts, or threat intelligence analysts, or forensics analysts. Anybody who's looking at malware, and especially evasive malware.
But I love what you've done. I mean, you explained terms. It's like you don't just jump straight into it. Like you explain what a stack is and what the heap is, right? So perhaps you can just give us like the 30-second overview what the difference is, because you did kind of mention them in this video or in the demo.
Yeah, sure, of course. So stack is like a temporary storage. Memory storage for programs that are running on Windows, and every program has a stack or multiple stacks. And a stack is very temporary. It will basically be created and destroyed shortly thereafter, after it's been used. And a heap is more permanent storage. Different threads in the program can write to the heap and can also read from the heap. In different capacities. So the heap is more, I would call it more of a permanent storage. But I mean, anything in memory, permanent is not the right term to use. But in this environment, we'll just say it's more permanent than the stack.
But I love that you've done this, because in the very first chapter, you're talking about Windows foundational concepts, and that's one of the things that you explain here. So I've got to ask you, is this book is it about Windows, or is it Android and other operating systems as well?
No, I decided just to stick with Windows on this one. First of all, it's what I know. Second of all, there is no malware for Android and Mac. Just kidding, there is. But I decided just to stick with Windows on this one. And it's what I know. And also a book on Mac and Android and Windows would just be too long.
Yeah, and I also think Windows is the most prevalent out there, right? So, I mean, it makes sense that you start with Windows. Or, I mean, if someone's starting, Windows is a great one to start with. You mentioned it multiple times in the demo, like a VM versus a sandbox. So what is the difference actually between a sandbox and a VM?
Yeah, that's a great question. I'm really happy we're clarifying that. I would put it like this. Almost all sandboxes are virtual machines, but not every virtual machine is a sandbox. A lot of times they're used interchangeably. But it's also quite important to differentiate in certain circumstances. So a virtual machine it runs in a hypervisor like VmWare or Virtualbox, right? It's a virtualized CPU, virtualized hardware, and it's a safe environment to run malware. Whereas a sandbox is also a virtual machine. A virtual machine runs sandboxes, but a sandbox is designed to run malware in more of an automated fashion and usually at scale. So a good example of a sandbox would be like Hybrid Analysis Sandbox or AnyRun or trying to think of some other free sandboxes. Like VirusTotal, for example, has a sandbox built in, not their detection engine where they rate the number of detections for the file, but they have a sandbox in the back end that runs and analyzes the file. So these are sandboxes, and they run malware at scale, usually very, very large number of samples. They're designed to quickly detonate the malware, capture all of its behaviors, and produce some kind of report for dissemination, and also for intelligence analysts and malware researchers to look at the report and realize and understand what's going on. Whereas a virtual machine environment, if it's not like an automated sandbox, it's more of like, for example, my Windows machine was a virtual machine environment where I'm kind of manually poking at the code, looking at the code in IDA or in a debugger and things like that.
Yeah, because in the book, I see you've got Cucci, I think, and Joe Sandbox. Those are the pictures that I see in the book. So that's what I'm mentioning, right?
Yeah, I actually have quite a few I mentioned in the book, scattered throughout the book. I probably mentioned like 5 or 6.
Do you like Joe's Sandbox as an example?
Joe's Sandbox is a really, really good sandbox. I do use it often. I did mention Cucci as well in there. Cucci is an open source sandbox. It's not currently being maintained, but there's a new version supposed to be coming out soon. But I mentioned that in the book because it's one of the few open source sandboxes that it's available for anyone. Most sandboxes are closed source. They're not always proprietary, like in the terms of they're not always paid for. Some of them are free, but free in the sense where any malware you're uploading to those sandboxes is going to be available publicly for everyone. So it's kind of like a free service they're providing, but free is not always free, So it's basically that information that's being used. That's kind of how it's funding its services. So that's maybe one thing to keep in mind. If you're going to use a public sandbox, it's helpful to kind of be aware of where the file is going and what's in the file before you upload it to a public source.
Now, what you've demonstrated, I think, is only chapter 4 and chapter 8, basically, and a little bit sprinkled in between, right? I mean, you did a whole demo just on those 2 chapters, kind of. Is that correct to say?
Yeah, exactly. Chapter 4 covers a lot of these registry checks that we covered, and then chapter 8 is about not so much detecting a sandbox, but what happens after a sandbox is detected. So that's kind of there's 2 steps in that process. It's malware will try to detect the sandbox, and then once the sandbox it determines that it is a sandbox or a hypervisor VM environment, it will then take action. And what the action will take, for example, it could terminate itself, or it could malware has even been known to kind of mess around with the malware analyst to exhibit different behaviors than it otherwise would. Yeah, that's what chapter 8 is about.
I mean, there's so much to cover. I mean, I love this. I'm sure the audience will like this. Chapter 14 is Introduction to Rootkits. So what's that about?
So chapter 14 is a very condensed rootkit chapter. And I say condensed because there's already been whole books about rootkits. So I had to take the most common techniques from rootkits, or at least the most important that I saw as most important, and condense them into a chapter. And the reason I have that chapter in there is because rootkits I can't have a book about evasive malware without talking about rootkits. I mean, rootkits are basically essentially the be all and end all of evasion, right? That's the being at the root of the system, or being at that low level is how malware is the most stealthy. So I had to include it. But yeah, I think it's a really good intro to how modern rootkits operate. And it's one of my favorite chapters, to be honest.
And then I also love this, like chapter 15, fileless, living off the land, and anti-forensic techniques.
Yeah, that's so fileless malware is there's different types of fileless malware, but a lot of modern malware will try to touch the disk as little as possible. And that's because in classical forensics scenarios, it's heavily relying on the disk as evidence. Memory is a lot more volatile. And memory will be, if the system is shut down, if the system is rebooted, if, for whatever reason, the artifacts or the evidence is not in memory anymore, it's gone. So malware will take great lengths to stay in memory and not touch the disk. So that's what that chapter is about. It's basically using different fileless techniques. One of those techniques is lull bins, which is living off the land. Of course, living off the land can also be used for other purposes, not just for fileless malware. But I also cover a lot of living off the land in that chapter. And then finally, anti-forensics, which is exactly as it sounds. It's malware that's trying to disrupt the forensics process by destroying evidence or what have you.
I'm assuming in chapter 16, you've got encoding and encryption, you're covering base 64 and other sort of ways to kind of obfuscate your code or something. Is that right?
Yeah, exactly. Covering exactly base 64 encoding. So basic encoding is like that. I'm also covering XOR encryption, encoding, however you want to define that. So XOR is basically a very fundamental unit of encryption technology. So I have to cover that. I also cover some encryption protocols in there as well. But what I was trying to not do in that chapter is just talk about encryption and kind of beat you with math. That's not what I intended. And I think what the chapter does, in my view at least, is it really gives a practical guide on how to analyze generically encrypted malware. So not taking into account a certain encryption standard, but taking into account just general encryption and how would you kind of get around that in malware analysis.
I mean, we could be here the whole night or the whole day, depending on what time it is where you're based. A lot of great stuff in this book, Kyle. I'd recommend anyone who's interested in this, go and buy this book. I think what we need to ask you, Kyle, and ask the audience is what we're going to get you back to talk about. I think the demo was amazing, and I think it would be great to have you demonstrate some more of this stuff. Like perhaps, audience, tell us what you want us to cover, like rootkits or base 64 encryption, or how malware tries to do that, and then Carl, how you can find out what it's doing and reverse engineer that.
That sounds awesome.
Carl, I really want to thank you for sharing. And, unlike perhaps, other authors who just talk about their books, I really want to thank you for actually putting the work in and doing a demonstration. Because, like I said, when I saw your pre-demo for this interview, the penny just dropped for me. It's so much nicer to actually see it than it is just to read about it or, to try and imagine what you're doing. It's so great to see it. And then, being able to read the book and tie it back to this. Really appreciate you putting in the work. And thanks so much for, writing this book and for sharing with all of us.
Thanks, David, so much. I really, really appreciate you inviting me on the channel. Had a great time. As I mentioned, I've been a fan of yours for a long time, so really happy to be here.